Namaste. In this video, we are going to see about finite automata. Finite automata, as we have already seen, temporary memory will not be there. Here, we will have only the input and the output. Input will be string, and the output we are going to see whether the string is accepted by the automata or rejected by the automata. Now we'll see the automata, finite automata representation. The representation is a state diagram where here this Q0 represents initial state and each circles Q0, Q1, Q2, Q3, Q4 and Q5 represents different states, and this arrow mark points the transition from one state to the other state on reading the input, and this double circle represents accepting state or final state, and the state where from that state we cannot reach any other state, that is called as dead state or a trap state. And then because this is a finite automata, here initially we have to define the input symbols or alphabets. So here input alphabets are A and B. So in each state I have to have a transition for A input also and B input also. That is important concept with respect to deterministic finite automata. We'll discuss that in detail. Next, we'll see how the input string A, B, B, A is accepted by this automata. As this is the initial state, we have to start from here. My input is A, B, B, A, and the first symbol is A, and the starting state is Q0. So after reading A, I can reach the state Q1. Next letter is B. After reading B, I can reach Q2. The next input is B. After reading B, I can reach Q3. The next input is A. After reading A, I can reach Q4. And now, after reading the input symbol, I am able to reach the final state. This determines that the input is accepted by the automata. Next, we'll see one more example which is rejected by the automata. The input is ABA. After reading A, I can reach Q1. After reading B, I can reach Q2. After reading A, I can reach Q5. Q5 is nothing but dead state. Once I reach the dead state, I cannot come back to the other states. So the input string ABA is rejected by the automata. So this concept is called as rejection, and the previous example explains acceptance of the string. Next, this is nothing but, we have already seen, this is an empty string. So after reading this empty string, I'll be on same state. And we are going to say whether it is accepted or rejected, because Q0 is not a final state. The input alphabet lambda is rejected, or input string lambda is rejected by the automata. Next, we'll see what is a language. We'll see the example ABB for this given automata. After reading A, I can reach Q0. After reading A, I'll be in Q0. And after reading B, I can reach Q1. So this example is accepted. Next, if you see, after reading B, I can reach the final state. After reading A, I am going to the trap state, and I'll remain in the trap state for any of the inputs. So that is rejected. So language is nothing but the language L of M, where M is a finite automata, contains all input strings accepted by M. So L of M is the strings that bring M to an accepting state. This is the language accepted by the finite automata. So for this, let us see what will be the language. So here, what can be the language? Example. One example is ABBA. I can have that string in the language, or what else I can have? I can have only ABBA. So here is a quiz question. Write any other string which is accepted by this automata. Next example, we'll see this, where Q0, Q2 and Q4 are the final state. If you see, here I have a double circle, here I have a double circle, here I have a double circle. So the final states are Q0, Q2, Q4. So here the language will be, after reading empty string lambda, I can reach the final state. The initial state itself is a final state, and after reading that input symbol also, I'll be in initial state, which is nothing but final state also. So lambda will be accepted. So the language, the set of strings inside this language will consist of lambda. Then after reading AB, I can reach Q2, which is nothing but an accepting state. So my language will consist of the string AB, and one more string I can have is ABBA. So as of now, lambda, AB, ABBA are the strings, set of strings in this language L of M. So this is the language L of M for this automata. Next, if we see, what is the language of this particular automata? So here, if you see, I have a loop. This is called as a loop, where I can read any number of A's followed by B, followed by AB, and followed by any number of AB's. But once I reach Q2, I cannot reach the any other states. So this is the trap state and this is the accepting state. So how I can write the language is any number of A's followed by B, where any number of A's represent, here I can have a A or not. So the n value is greater than or equal to 0. So we'll see the rest in the next video.